The learning goal for this video is to compare slope in different forms. Compare slope in different forms. So, what forms are we talking about? Well, when we're talking about any mathematical situation, they can be given in four different forms. Mathematical situations can be given in words, verbally, as a table of values, which is numerically, in a graph, which is visually, as an equation, which is algebraically. So the four forms are verbally, numerically, visually, and algebraically. And just a quick reminder that slope is equal to the unit rate, which was the point from our last lesson. In this example, we're going to compute the slope or unit rate of this situation. You purchase a plant. After 5 weeks, the plant is 7 inches tall. After 9 weeks, it is 12 inches tall. So this is one we've done sort of several times already, so I'll ask you to pause the video and work it on your own and maybe check with the neighbor, and after that I'll come back and show you my solution. So here's what I came up with. I made a table of values, and the input value was the weeks and the output value was the inches. For 5 weeks they were 7 inches tall. At 9 weeks, the plant was 12 inches tall. That's an increase of 4 weeks from 5 to 9, an increase of 5 inches from 7 to 12. So the unit rate, which is also the slope, is 5/4 inches per week. In this example, we're going to compute the slope or unit rate of this situation. The growth of a plant is given by the following equation, where h represents the height in inches and t represents time in weeks. H equals 2/3 t plus 5. So for this problem, I'm going to suggest that we make a table of values. So the input variable is t, and that is time in weeks. The output value is the variable h, and that represents height, and the units there are inches. So a quick table of values there. Now, with an equation, our job is to come up with the input values, and so probably the easiest input value for this equation that I could just suggest is 0 weeks. And because we know that 0 times any number is 0, so we've got 2/3 times 0 plus 5. Again, 0 times any number is 0 plus 5. That gives us a height of 5 inches. Incidentally, this means that at the beginning of this process, when we bought the plant, let's say, the plant started off at 5 inches of height. Now, coming up with the other values for the table of values here, you might be inclined to try, you might think about trying 1 as a value, but if you think about it, if you take 1 times 2/3, that equals 2/3, not too bad, but then you have to add 5 to that, and you get 5 2/3, which is okay until we actually have to compute the slope or the unit rate. So I'm going to suggest we skip that for now. If you wanted to, you could deal with that, but I say it'll make our lives a lot easier if we keep going. So the key here is that it's a 2 divided by 3. So this 2 divided by 3 tells us that probably a better number to put for our time input value would be 3. So what we'll have here is 2 divided by 3 and then multiplied by 3. Well, those are opposite operations, so the 3 and the 3 undo each other, and so plus 5 there. We've got 2 plus 5, that gives us a height of 7. So now we have a table of values, 0 weeks, 5 inches, and 3 weeks, 7 inches. Go ahead and pause the video and finish up computing the slope or the unit rate, and I'll come back and show you my answer in a couple minutes. So let's see how you did. I saw here that from 0 to 3, the time increased by 3 weeks, and from 5 to 7, the height increased by 2 inches. So the unit rate or slope for this problem was 2 inches per 3 weeks, or 2/3 inch per week. In this example, we're going to compute the slope or unit rate of this situation. The growth of a plant is represented in the following graph, where the horizontal axis represents the time in weeks and the vertical axis represents the height in inches. So I'm going to suggest again that we make a table of values in order to compute the unit rate or the slope. So the input value is going to be time, and this is in weeks. The output value is going to be the height, and that unit is in inches. So there's our XY table. Now, to find the actual coordinates, we're going to have to find points that cross at whole number or integer values on the graph. And a good place always to look is along the y-axis here. And so if we go here, we see this point right there, and let's identify that as 0 along the x-axis, comma, -1. So we have a 1 point there. So time would be 0 weeks, and the height would be -1 inches. So this, from our previous lesson, might mean that the plant was underground, or the seed was underground and the plant was growing at the time. Looking along the graph here, I think we can identify another point here where the x value is 2 and the y value is 6. So, or the output value is 6. So we have a time of 2 weeks and a height of 6 inches. So go ahead and pause the video and compute the slope or unit rate, and we'll come back and compare my answers with yours in a couple minutes. So how did you do? I saw here that from 0 weeks to 2 weeks, that's an increase of 2 weeks. From -1 inches to +6 inches was an increase of 7. So the unit rate or slope for this situation was 7 inches over the course of 2 weeks, or 7/2 inches per week. So I want you to pause the video and discuss with your neighbor what happened in this problem. So the learning goal for this lesson was to compare slope in different forms. So in example 17 here, you're going to look back at the examples 14, 15, and 16 and list those situations from least to greatest slope. And in that way, you're going to compare the slope from different forms. So go ahead and pause the video and look and compare and list examples 14, 15, and 16 from least to greatest slope. Alright, so I have listed the slopes, or the rates of change, or the unit rates for the examples here: 5/4 inches per week, 2/3 inches per week, and 7/2 inches per week. So in doing this problem, I think we can use a shortcut and say that 5/4 and 7/2 are both greater than 1, and 2/3 is less than 1, so we can immediately list example 15 as the least slope. So to examine or compare the other two, we'll find a common denominator. So 5/4 and 7/2, the common denominator is going to be 4. So for this one, we're going to equate it to denominator 4 here. 2 times 2 equals 4. 7 times 2 equals 14 inches per week. So we compare now and say 5/4 is less than 14/4. So the next answer is example 14, and finally example 16. And so hopefully you also found that the list from least to greatest slope was example 15, example 14, and then example 6. So now we're going to move to a mid-lesson check. And what I want you to do by yourself, or maybe with your neighbor, is to identify the form represented in each of the 3 examples with the form that was shown in that example. And go ahead and pause the video while you do that or discuss with your neighbor. So example 14 was one where we were given the situation in words. Example 15 was an equation. example 6 was a graph. So the next question here, which form was not represented by one of the three examples? And clearly that was numerically or table of values. And I want you to discuss this next question with your neighbor and maybe as a class. Which of the other three forms does the missing form most closely match? So table of values, which one does it more closely match? In words, in a graph, or as an equation? Okay, well, which of the other three forms does the missing form most closely match? Well, there isn't really a definitive answer to this question, but hopefully you had a good discussion amongst your classmates in talking about this topic. In this next example, you're going to list the following plant situations from least to greatest slope. So you have here part A, a table of values, part B, an equation, and part C, a graph. So go ahead and pause the video and work these problems by yourself or with your neighbor, and then I'll come back and show you my solutions. So here's what I got. In example part A, from 1 to 7 is an increase of 6, and from 12 to 15 is an increase of 13, so the slope is 13/6. And in the second part here, I went with 0 because that's the easiest number to substitute, and 5/2 times 0 gives you 0, plus 7 is 7 as the height. And again, the denominator being 2, I used 2 for the input value, so 5 divided by 2 times 2 gives us 5, plus 7 gives us 12. So overall, an increase of 2 here and an increase of 5 there gives us a slope of 5/2. With the graph, I again went to this the y-axis here and see that the graph crosses at 0, 1. Another point that I identified was 4, 8, and created the table of values there. An increase of 4 and an increase of 7 gives us a slope of 7/4. Now, to compare these four slopes, we'll have to find a common denominator. So I think we can see that 6, 4, and 6, 2, and 4 has a common denominator of 12. So let's go through here and make that a 12 there. 6 times 2 equals 12. So 13 times 2 equals 26. And here, a denominator of 12. 2 times 6 equals 12. 5 times 6 equals 30. And a denominator of 12 here. 4 times 3 equals 12. 7 times 3 equals 21. So listing them in order, the lowest one is going to be 21 over 12, so that would be C. Next we have 26 over 12, which would be A, and then 30 over 12, which would be B. So hopefully you got the same thing. And so I want you to pause the video and discuss this whole problem with your neighbor. To finish the lesson, I want to remind you that the learning goal for today was to compare slope in different forms. And to wrap things up, discuss these questions with your neighbor and maybe with the whole class. What are the 4 forms for mathematical situations? What do you do to calculate the slope for each of the different forms? Once you've calculated the slopes, what has to be done in order to compare them?